Good morning, everyone. I'm very proud to be here to present the project Big Data Bias Detection. Our main aim has been to use the RAI Dataset to understand how the different sources that our national broadcaster uses, how they talk about different topics, how they use the words inside their titles to communicate their newsfeed and different news. So our idea is to see if they are in some sense using a bias to communicate. And we are a very great team of 4 people. We are a little bit tired, but we have something to present today. We are composed with Erika, a PhD student in design of Politecnico di Torino, Piero, PhD student in Bari, David, a future PhD student, maybe, in Barcelona, and me, maybe a startupper. And okay, as I said, our goal is to show the topic inside the RAI dataset over the time, how they are evolving, and which sources are using particular words for communicate some topics. So our expected result is to see different sources use some common words to communicate a topic. And we are doing this with a very long and complex data analysis part with clustering and then visualization, a dashboard for the visualization. Let's start to speak about a little bit of our starting point. Okay, I want to also to thank the RAI for this dataset. The dataset is composed by 2 million rows, and the time span is from November 2010 to December 2012. The line of the dataset, the atomic part, is very simple. It's composed by an identifier that we discover is not unique, a timestamp that identifies the time that the RAI used that link for their news media platform, and obviously the URL and the news title. Okay, I'll pass the word to Piero for the data analysis.
Yes, I can also add that there are other fields, but we are not using them. Also, for example, the field before news title is the data source. There should be one different number for each feed source. But we discovered that it's not really, how to say, it's not really consistent with the URLs and also with the domain levels of the URLs, so we choose to use them to do some grouping, and so we choose the second level URLs for finding different sources, and then as the different sources are somehow replicated, like for example, Tuttosport, which is a sports journal, was the news from Tuttosport were taken from both the Tuttosport website and other feed sources that gave different articles from also Tuttosport, and so we aggregated them. And at the end, we also filtered the data just to go from January 2011 to December 2012, just to have a 2-year snapshot and to visualize it in a better way, probably. So the steps of filtering starts with just really simple language filtering, which uses an LTK, which is a Python library for doing so, and it's just stop word removal. So all the words that brings less meaning are removed, like the determiners and other kind of adverbs. Also, all the titles were tokenized, and all the characters that are not alphanumeric were removed. And so this, you can see one example of one topic that one title when as it was before the filtering and after the filtering. So using scikit-learn, we did mainly two big steps. The first is TF-IDF vectorization. So from all the titles, we obtain a matrix with words and as rows and titles as columns. And the values inside are, roughly speaking, the frequency of that word in that document, and divided by the number of that word in all the documents. So it balances the frequency of the word with how common this word is. After having this matrix, we did, how I call it, fuzzy clustering. And to do so, we used non-negative matrix factorization. So we had this big matrix for 20,000 words by 2 million documents, which are the titles of the documents, really. And we obtained two different matrices. One is as 2,000 rows, which are the words, and just a selected number, we choose 20 number of different topics. And the other matrix has 20 topics per all the 2 million different documents. So basically, what we have now is a weight for each word, for each topic, and a weight for each document, for each topic. We use these weights to in MapReduce, we use the Mr. Job on Amazon AWS for doing the job. And we obtained some aggregate values in order to compute, to display a graph and put the weights on this graph, and also to compute the trends over a timeline, over the 2 years timeline, in order to display if there are peaks or different things that can be shown on the timeline with regard to the different topics. And so it took 30 minutes to compute all of this in 10 machines of the M1 extra large on Amazon AWS to do so. And okay, now maybe David can talk about what the generated JSONs are.
Ciao a tutti, hello. Let me recap. Okay, thank you. Since using the data we've defined, and we expected especially to find 3 different huge dimensions that are referred to how are the topics of the word they have, how it's the time evolving, and also which are the sources. The problem is that the MapReduce job, of course, takes time. So in a way of production, it was not reliable to try to do a completely straight work. So we've done with Francesco was to define an structure that was able to visualize the data we were expecting, generate some random data structure, and create a visualization with that random structure. Meanwhile, we were expecting the meaningful data. Okay, so since we wanted to show especially three things that are how the topics evolve in time, how the sources and the words interact, and how the words are inside the clusters, we defined 3 different kinds of JSON files. Okay, the first one it's the force graph, so it's the one when the words interacts with the sources. Mainly what we are showing here are 2 different data sets as any graph between the edges and the nodes. And inside each node, we have its definition. So in this case, it's the name and the type, because the nodes can be even the sources or the words. And then we have inside a matrix called clusters, where we define how these nodes should behave inside the topic. So we are able to display for the same graph how the words are related in a general point of view or inside each topic. Probably you will understand this better when you see the final visualization. Okay. Then we have the timeline, where we are trying to show how the topics evolve in time. This is a really simple data set with just, for each topic, which are 13. Maybe it's a bad number. Maybe the 13 number was the cause of these GitHub problems. So for each one, we have how the intensity evolves in time. So we are able to display for each one a timeline evolving. And finally, we have the cluster graph. So it's, again, the 13 clusters. And inside each of them, we have the word that defines them and which weight, how much is weighted this word inside the scope of the topic. OK, finally, we use it to display everything D3. It was a really funny job. I get at least a lot of fun. Probably, I think it's the most big work I've ever done in JavaScript, so I'm quite happy about it. And it was nice because we are displaying completely 3 different SVG files. But as D3, after all, it's just a complete DOM manipulation. You can manipulate even this SVG or the HTML or whatever. The 3 SVGs are completely interacting between them and are explaining a meaningful data, all of them at the same time. And I let our great designer, Erika, to explain how is the user interface.
So, as we seen before, we have 3 different type of graph. This structure is the same also in the screen. So we have on the left a control panel in which we show the cluster and that is interactive. On the right side, we have the main visualization, that is the first graph. And on the bottom, we have the timeline graph. But I think that if we... okay, possiamo... we have also to see the design details. So we choose a basic palette and an extended palette to represent all the visualization. Then we use also a font face and a normal usual font. So this is the interaction. So on the left, we have this interaction that shows all the cluster, each cluster. When and on the right, we have the diagram force. On the bottom, we have all the clusters represented by the time. If we click on one of the cluster, the diagram force is filtered by this cluster and it changes. On the bottom, we also see the timeline, the amount along the timeline. So this is the interaction that we can see. Okay, let's analyze some, Piero, some data. So the results. For example, the most used. Okay.
This is the best trend in the sense that it's the trend that most of the news belong to, and this is about probably. Okay, the words inside the cloud are unsupervised learned. So we put just a label in the top right just to give an idea of what this topic could mean. And basically, this is about the crisis in Europe, and it talks more about banks and also a little bit of economy and. Yes, also Spain, and this basically is you can see that the sports journals like Corriere dello Sport and Tutto Sport basically are not really connected to most of the words, and this means that basically they are not talking about this topic in a relevant way. Another really interesting thing is that, for example, when you talk about where is the here it is. Here, for example, about this is a topic which talks most about the TAV, the train that should be the works about the TAV that should be done or they shouldn't be done. It depends on how you feel about it. And this is a pike, for example, in the news, which is corresponds to manifestation. No, manifestation. Sorry. In Rome, so they do some big riot in Rome about it, a big protest in Rome about Notav, and so this is quite meaningful. And also you can see, for example, it's really related to Turin because okay, it's in Piedmont the problem about the TAV, and it's really connected to La Stampa, and also this is a good thing for Torino maybe. If we talk about cultural events, the only city that shows up as a word used is Torino. So probably this means that in this city there's something good going on probably.
So, yes, because during 2011 we have the 150 So we can see that in the first period of the year we have a more intensive notice related to for example, 2012. So Torino has a central position and is connected really with La Stampa, that is the local newspaper.
Yes,
if we go.
Okay. There's not really a lot of fuss about the election, but it was okay before the election, so they are in 2013. But something meaningful that could be found here is that, for example, if you where is it? Sorry, I cannot find. Okay, for example, Vendola is only connected to where is it? L'Unità e la Gazzetta del Mezzogiorno, which is something okay meaningful also because it's from Apulia, and so Gazzetta del Mezzogiorno talks about it, and also left-wing journals talks about him, but at the same time the sports journal doesn't talk at all about politics, just the Gazzetta talks about Berlusconi sometimes, but maybe it's for soccer, for football reasons. And yes. Okay, here, for example, we have that the sport. Sorry, this is one. Yes. Where are them? Oh, okay. Sorry. Okay, good. Okay, here we can see, for example, that most of the journals are connected to the most general words of this topic, which is basically a topic about sports and about Italian soccer league or football league. And while the name of the teams are really divided by from the general kind of words. And so, for example, these words ancora, senza, solo are from one side, and Juve, Milan, Inter are from the Lazio for the other side, and they are more used by, as one can expect, sports journal and so on. And what else? Okay, maybe it's enough, but if, we will put this online so anyone can take a look at it and maybe find something more, even something more interesting than this.
Yes, during.
Just one fast thing. Finally, there is one feature that it's not inside the visualization. As you can see, we are mostly displaying just newspapers, so portal webs that also are printed. But we categorized all the sources we were analyzing between newspapers, press agencies, and just web portals. And we should have the feature when you can swap from one to each other. It's already implemented, but just so some books that we didn't wanted to solve meanwhile the other presentations. This is the reason why you don't see here, but you can even explore this other new dimension on how this change between the agencies and the newspapers. Just yes?
Another add. Maybe it's meaningful to say that the titles of each topic it's manually added. So we had a cloud of words that define that cluster and that topic, and we decided to give that name because, as Piero said, there was an unsupervised clusterization. So, what? But we are honest here. We are not to sell anything.
Yes, we want to be scientific, but we want also to help the usability for the user. So we put the word to summarize. Yes. So we at the beginning we find 105 sources, and then we filter all of these sources, and we decide to collect 20 sources from newspaper, 10 from news agencies, and another 10 from the web portal. At the beginning, we have all the schema, all the force schema with a lot of sources, so 40 sources. There were too much, so we decided to filter only by newspaper, and this is a failure for us, but we adjust it. Then
what else? What else we have done? For the topics, we learned 20 topics, but we selected only 13 more relevant. This was done by hand. That's just because some of the topics were really narrow. For example, there was one topic which was just numbers or words about numbers. So it's probably not really meaningful to show the trends of how the words about the numbers are used in newspapers. But okay, we did it by hand, so that's a little bit of fail, but we can improve on this. And at the end, the visual clustering of the words and different data sources could be better, and we have not added links between words, which could have been. Oh, maybe we have another slide on this. Yes, could have been really useful if we added the pointwise mutual information, for example, between two words, which approximate semantic similarity between two words. We could have had a better clustering, but due to time constraints, we just displayed this, and probably this is a good step for improvement in this visualization. And also, we could add more statistics, for example, for each data source, how are the topics distributed over the single data source, and all these kinds of information. This will be added maybe in the next future. And that's all. Thank you for your attention. If anyone has some questions, we are.
Yeah, you may have said it, but I don't remember. How many tokens were in the dataset?
Yes, in the datasets there were something like more than 100,000, but we have taken only the best 20,000 words to build the matrix, and then just to display the graph, we took just the top 20 words for each topic. In order to, it's just a reason of to make the display clear, to make the graph clear.
Two matrices that give a yes, and the other one were 20,000 rows.
By 2 million, yes.
Why all this power for this matrix?
Sorry?
A lot of instances to analyze it.
And
It's huge, but not.
yeah, yes, okay. The good point was it's. The best, no. The point is that the matrix is really sparse, And this is really helped us in analyzing it. But still, we didn't put this whole matrix on Amazon to do the MapReduce. We just put the 2 million rows. We've added all the results from the matrix. So the file we uploaded was maybe 2 gigabytes. Probably it's still small for Amazon standards, but it was really big for our computers to compute it. So that was our main reason for using Amazon, more or less.
For a final conclusion, maybe this tool can be extended and also used for data journalism, because as you can see, it's a dashboard to understand for a journalist how a topic is faced from different sources. So it could be a service, or could be also an open source service. And in that way, I think that we could release in the next days on GitHub. So if you are interested, just tell us about it.